So this is another way to work one of these problems. In this case, we're going from a liters and a moles of one thing to molecules of something else. So not moles of something else, but molecules of something else. So you just want to make sure you follow the steps. It says that it's oxygen, 0 oxygen, H2, O2, plus H2. And we've seen this reaction already in the notes, but if you didn't recognize it, it makes H2O. And then you want to make sure that it's balanced with a 2 and a 2. And then it's telling me that I have, luckily this is already in liters, 2 liters, and I have that many molarity. And it wants to know how many atoms of hydrogen exist in the water formed. So it wants to know atoms of H. So this is a few extra steps, so that's why this is a good thinking problem. If you can do this one, you're going to be set and good to go. So I always rewrite molarity as moles per liter, scribble them out. And the only unit I have to start with is this 2. So 2.0 liters of oxygen. And I got to get the oxygen to head over towards being water to begin with. And so, again, my molarity, I know that I have 6.0 moles of oxygen in 1 liter of solution. And then now that I'm in moles, I can go from moles of oxygen to moles of water. Now, if it had asked about how many molecules of water, then that would have been fine. If it had said how many atoms or how many molecules of water exist or are formed, then I would go from moles of water to Avogadro's number of molecules of water. However, this isn't asking about the water. So what we need to do is go from moles of water to moles, my pen is being crazy. We need to go from moles of water to moles of H. Now, this is really tricky because you're going to want to be tempted to say H2. So H2 is a molecule. It wants to know atoms of hydrogen. So if anything ever asks you for hydrogen or for atoms, it's not asking for the diatomic form of it. It's asking for how many single little atoms that there are. And so in this case, there are 2 and 1, and that's because of that subscript there. And then in this case, I've got 1 and 2, and that's because of those subscripts. Oops, yeah, water, oxygen. And then the very last bit, it doesn't want to know about moles of H, it wants to know about atoms of H. So 6.022 times 10 to the 23rd atoms of H. Like I said, it would have said like molecules of H, of hydrogen or something, if it was going to be H2. And our units cancel, so liters of oxygen, there's oxygen, there's water, there's moles of H, and I'm left with atoms of H. So 2 times 6 times 2 times 2 times 6.022 e to the 23rd. Notice that exponent, and I've got 2 sig figs, so my answer is 2.9 times 10 to the 25th atoms of H.